Hello friend, welcome to Technizar. This is Rohit Sharma and today is our video number 2, that is 12th November. Okay, and video number 2 is based upon nodal and mesh analysis. In the last video that is the basics of network theory, I have completed the equivalent circuit of resistor, inductance and capacitance, what are current, voltage, charge, etc. Okay, some numericals based upon KCL and KVL. So in this video we are going to complete nodal and mesh analysis, and those students who have not subscribed the channel, please subscribe the channel and just follow this 45-day strategy to crack the exam. Okay, I will complete each and every part in this 45 videos. Okay, and this will be free of cost on our YouTube channel. So please go and subscribe the channel, and quiz tournament is also going on our Technizar app daily at 7 PM. So please go and attempt the quiz tournament so that you can prepare well. Okay, so one important announcement is there. Those students who have not purchased the ISRO TA crash course, so I have completed each and every basic concept to advanced concepts in this ISRO TA crash course. Well explained concepts are there, good number of questions are taken, and more than 180 plus videos are there. Okay, so next ISRO TA test series is also available on Mechanical Adda app. 15 basic tests are there, 7 mixed tests, 2 numerical tests, 16 full syllabus tests, and total of 2000 questions are there. So subject-wise courses are available at Technizar app, and quiz tournament is going on free of cost, so you can check it out at Technizar and also on Mechanical Adda. Okay, and I want to share one important news. As per Diwali offer, 25% discount is available on all the courses if you purchase it. Okay, 25% discount is there. So now I'm going to start the video, that is mesh analysis. What is mesh analysis? Mesh is a loop which does not contain any inner loop. Okay, first of all, it is applicable only for planar network. And what is a planar network? A planar network is one that can be drawn in a plane with no branches crossing each other. What is the procedure for applying mesh analysis? First of all, identify the total number of loops or total number of meshes. Then assign the mesh current I1, I2, etc. Third, develop the KVL equation. Develop the KVL equation for each mesh, and last, solve the equation. Two notes are there. The direction of mesh current can be taken in any direction, clockwise or anti-clockwise, but I take clockwise because of the simpler analysis. Okay, so you can also take clockwise. Okay, then second one, how to find the number of equation. This part I have seen many times in your ISRO exam. To find the number of equation by using mesh. Okay, so formula is b minus of n minus 1. What is b? B is the branches, n is the number of nodes in the circuit, and minus 1. Okay, this is how you can solve this, and you can also write it as b minus of n plus 1 can also be the equation on opening these brackets. Okay, so please remember this. Now let's take first question based upon mesh analysis. So this is the mesh analysis, and you have to find this current I. Okay, this is the 5 ohm resistance, this 5 ohm, this is 10 ohm. So first of all, I am seeing that there are two loops. First this loop, and second one is this. So I am assigning mesh current. This is I1 and this is I2. Remember, the current that you have assigned, both should be in clockwise or both should be in anti-clockwise. Okay, so now I am writing the KVL equation for loop 1. Okay, for loop 1, minus 10 plus 5I1 plus 5. In this 5 ohm resistance, both the currents are going, I1 and I2. Okay, so this will be equal to 5 of I1 minus I2 is equal to 0. On solving this, you will get 10 I1 minus 5 I2 is equal to 10. Okay, and 2 I1 minus I2 is equal to 2. This will be our first equation. Now in loop 2, 10 I2, this current is flowing, 10 I2 plus 5 of I2 minus I1 here. 2 minus I1 is equal to 0. You will get minus I1 plus 3 I2 is equal to 0. This is the second equation. Now when you solve equation 1 and 2, solve equation 1 and 2, you will get I2 will be equal to 2 upon 5 ampere, and I2 is equal to this I current that we have to find. So I is equal to 2 upon 5 ampere by using mesh analysis. Okay, this is how you can implement a mesh analysis and find the value of current, voltage, etc. Okay, so here this the value of current is 2 by 5 ampere. Let's see one more question based upon mesh analysis. Some students said, some students tell me that sir, whenever a dependent source come in the circuit, we unable to solve the circuit. So let's see how a dependent source acts here. So there are 3 loops here. Okay, there are 3 loops here. Let's see these 3 loops. What are the 3 loops? Can you tell me? So let's see. This is the loop first, I1, loop 2, I2, and this is loop 3, I3. And remember, I3 is equal to I that we have to find. Okay, so first I am applying KVL in loop 1. Okay, in loop 1 you will get minus 5 plus 1 I1 plus, in this 1 ohm resistance 2 currents are flowing, I1 and I2, so this will be 1 bracket I1 minus I2 is equal to 0. From here you will get 2 I1 minus I2 is equal to 5. First equation, this is that. Now I am applying KVL in loop 2. In loop 2, 1 I2, okay, 1 I2 plus, in this I2 minus I3 is flowing in this, so 1 of I2 minus I3 plus 2I, this dependent source I am taking as it is here, okay, plus 2I, and this again here 2 currents are flowing here, so 1 of I2 minus I1, which is equal to 0. From here you will get minus I1 plus 3I2 minus I3 plus 2I is equal to 0. This is the second equation. Okay, so next is our loop 3, third loop equation. So this will be I3 minus 2I, okay, plus I3 minus I2 in the 1 ohm resistance. Current flowing in the 1 ohm resistance is equal to 0. From here you will get minus I2 plus 2I3 minus 2I is equal to 0. Third equation. This is our third equation. Now if you see these 3 equations, we have to find 4 variables. I1, we have to find I1, I2, I3 and the dependent source current I. Now we have to find 4 variables, but we have only 3 equations, so we will not able to solve this. So we want one more equation. Now from here you can write I is equal to, the current I is equal to I1 minus I2. Okay, in this branch the current flowing in this branch I is equal to I1 minus I2. I can write this I1 minus I2. This is our 4th equation. Okay, so please remember this 4 equation. Now you have to solve this 4 equation to find the value of I3 current. Okay, so let's see this how we can solve. Now I'm putting the value of I equal to I1 minus I2 in the second equation. From here you will get I plus I2 minus I3, sorry, I1 plus I2 minus I3 is equal to 0. This is our 5th equation. And similarly you are putting 4th equation in 3rd equation. From here you will get minus 2 I1 plus I2 plus 2 I3 is equal to 0. This is 6th equation. Okay, on adding these 5th or 6th, on adding this 5th or 6th, or you can also, one second, now you can see equation 1 and 6, or you can simply solve by yourself also here. Okay, you can see equation 1 and 6. From here you will get I3. I am directly calculating the answer. I am writing the directly writing the answer here. So I3 you will get from here is 5 by 2 ampere, which is equal to I3 equal to 2.5 ampere. The main thing is in this question is, first you have to, how you can assign these 3 loops I1, I2 and I3, and how you can write the equation loop 1, loop 2 and loop 3, and after I is equal to I1 minus I2. Now it is easy to solve, just you have to implement substitution method that you have studied in class 10th. Okay, substitution method, you have to substitute the values here and there and you can find the value of current I3, I1, I2 that is asked in the question. Okay, so I am writing I3 is equal to 2.5 ampere. So please check this answer. If it is correct, so please let me know in the YouTube description section, YouTube comment section. Okay, so next is the nodal analysis. What is nodal analysis? Let's see this. Okay, so nodal, first the procedure for applying nodal analysis is, let's see this, identify the total number of nodes. Okay, this is not matches. Okay, identify the total number of nodes. Okay, so let's see, sorry, one second. This is identify the total number of nodes. Okay, assign the voltage at each node. One of the node is taken as the reference node, and the reference node potential should be equal to the ground potential. Now develop the KCL equation for each non-reference node, and you can solve the KCL equation to find the nodal voltages. Now notice it is applicable for both planar and non-planar network. Okay, if in my opinion nodal is easier than MASH. Okay, nodal is easier to implement than MASH. Okay, because the number of equations are less in nodal analysis. So here the number of equation is total number of nodes minus 1. So suppose in a network there are 4 nodes, then 4 minus 1 is equal to 3 equations will be there only. Okay, so this is easier to solve in my opinion. Okay, so you can solve each and every question by this nodal analysis. Okay, so let's see. Now I am taking this as a ground potential. This is the reference node. Okay, so these are the non-reference node. This. Now you can see all these nodes have the same potential because there is no element between these 3 nodes. So I am taking this as a single node, that is V1. Now I am applying nodal analysis here. Okay, so here the current I1 is flowing like this, here I2 is flowing like this, here I3 is flowing like this. So by applying KVL I can write I1 plus I2 plus I3 is equal to 0. Okay, so what will be the value of I1? I1 will be V1 minus 4 upon the 1 ohm resistance. Okay, so V1 minus 4 upon 1 ohm resistance, plus I2 will be V1 minus 2 upon 1 ohm resistance, plus I3 will be here the current is already flowing, so this will be minus 2 ampere. Okay, this will be minus 2 ampere is equal to 0. So this will be equal to 2V1 minus 6 is minus 6 minus 2 is equal to 0. So 2V1 is equal to 8 and V1 is equal to 8 upon 2, which you are getting as 4 volt is the nodal voltage. So this is the one simple question on nodal analysis. Now I will take one good question on nodal analysis in which dependent source is there. Okay, so many students are saying that the dependent source questions are tough to solve. Okay, so I will, and now here we will see how we can solve these type of questions. Okay, in the below given circuit, find the power delivered by the 2 volt source. This is a 2 volt source. Okay, minus plus 2 volt source. Here you have to see what is the power delivered. Okay, so here are 3 nodes here, V1, V2 and V3. Okay, now at node 1 I am applying the nodal analysis at this node. At this node these are the current flowing here like this. The sum of current will be equal to 0. So here what will be the equation here? V1 minus 5 upon 1 plus V1 minus V3 upon 1 plus V1 minus V2 upon 2 is equal to 0. On solving this you will get 5V1 minus V2 minus 2V3 is equal to 12. This will be the first equation. Okay, same goes with at node 2 and node 2. This is going here, this is going here, this is going here. Okay, so at node 2 you can see this is the minus plus this 2 volt. So I can write V2 is equal to directly V2 is equal to minus 2 volt here. Okay, you don't have to apply nodal here. So this will be the second equation, V2 is equal to minus 2 volt. Now at node 3, what will be the equation? This. So V3 minus V1 upon 1 plus V3 minus V2 upon 1 plus 3V is equal to 0. Okay, plus 3V is equal to 0. From here, and we know that from here V is equal to this V is equal to V2 minus V1. This we know that. Okay, V is equal to V2 minus V1. On solving this you will get minus 2V1 plus V2 plus V3 is equal to 0. That is the third equation. Okay, now Now put equation number 2 in first, okay, that is the V2 equal to minus 2 volt. Put this into first equation, that is equal to 5V1 minus 2V3 is equal to 8. This is the equation number 4. And put equation number 2 in equation number 3. From here you will get minus 2V1 plus V3 is equal to 2 volt. That is equation number 5. On solving equation number 4 and 5, you will get V1 equal to 12 volt and 12 volt, and V3 you will get as 26 volt. Okay. So if you see this circuit, at node 2, okay, at node 2 you will get at node 2, if you apply nodal again, you will get the current flowing here in the 2 volt voltage source. Here you will get the current here. Okay, so I am taking the current here as I21, okay, and here I am taking as I22, and here I am taking as I23. So if I can write I21 by applying KCL, I21 is equal to plus I22 plus I23 is equal to 0. By applying KCL I can write this. Okay, so from here I22, we have to find I22, so I22 is equal to minus of I21 plus I23. So if I apply here, this will be equal to V2 minus V1 upon 2 plus V2 minus V3 upon 1. On solving this, putting the value of V2, V1 and V3, minus 2 minus 12 upon 2 plus minus 2 minus 26 upon 1. From here you will get I22 is equal to 35 ampere. Now what is the power delivered? So power delivered is equal to, we know that V into I, so power delivered is equal to 2 into 35, which is equal to 70. What will be the correct answer? Okay, so these are some questions based upon nodal and mesh analysis. If you have any doubt related to these questions, you can ask me in the YouTube comment section. And this is all about nodal and mesh analysis. If you want some more questions based upon nodal and mesh analysis, I can give it to you. Okay, till then, okay, bye bye, take care, and we will meet in a next video, that is tomorrow, video number 3. Okay, till then, all the very best, guys.